This is the Algebra 1B semester exam review for Unit 4, Topic 3. This is the formula sheet that will be given to you on the exam. You really want to pay attention to this, especially for this unit topic, because the quadratic formula is here, and the zero product property, Pythagorean's theorem, the distance formula. All of these are going to be really important things that we're going to be using in Unit 4, Topic 3. So for items 53 through 55, use your calculator to graph the function, then state the number of real zeros. So what you're going to do is you're going to press the y equals button on your calculator. You're going to put in each of these functions, and then you're going to press graph. The number of real zeros is the number of times the graph crosses the x-axis. Because if you remember, zeros are the same as solutions, which are the same as roots, which are the same as x-intercepts. So for 53, when we graph this, we get a graph that looks something like this. So we can see that we're going to have two real zeros. For 54, when we graph it, we get something that looks like this. It doesn't cross the x-axis at all, so there are no real zeros. Finally, for 55, when we look at the graph, we get a graph, sorry, this is really hard to see with my application, but we get a graph that crosses the x-axis at exactly one place, meaning the vertex is also the x-intercept. So in this case, we have one real zero. Question 56 says, Jack kicked a football. The height, h of t in feet, of the ball after t seconds is given by the quadratic function h of t equals negative 16t squared plus 64t. So part A asks us, after how many seconds does the ball hit the ground? Show how you determined your answer. Well, we're looking for when the ball hits the ground, meaning that the height is 0. So what we're looking for is when is h of t equals negative 16t squared plus 64t. When is it equal to 0? When is the height 0? So this is a function that we can actually factor by taking out the greatest common factor. So the greatest common factor is the largest number and or variable that can come out of every term in the function. Well, 64 is divisible by 16, so I can take out a 16. If my leading term is negative, I want to pull out the negative as well, and I see that I have a t, so I can factor that out as well. So what this is going to give me is 0 equals, I'm going to factor out a GCF of negative 16t, and in my parentheses I'm going to put the remainder. Negative 16t squared, essentially divided by negative 16t, is t, and 64t divided by negative 16t is negative 4. Using the zero product property, we can say negative 16t equals 0, or t minus 4 equals 0. Negative 16t equals 0, I'm going to divide both sides by negative 16 and get t equals 0. Or t minus 4 equals 0, I'm going to add 4 to both sides and get t equals 4. These are my two solutions. These are the two solutions I have when the height is 0. When the ball starts, it's at time 0. When it ends, it's at 4. So it takes 4 seconds, and you should always put your units, for the ball to hit the ground. You could have done this problem by the quadratic formula, completing the square, factoring as I did. There's multiple ways to get the same answer. Part B says, does the ball reach its maximum height at t equals 2 seconds? Show how you determined your answer. So again, we have our function h of t equals negative 16t squared plus 64t. You could complete the square in order to put the equation into vertex form, find out what the vertex is. But that's complicated because we have this coefficient of negative 16. When your equation is in standard form, the vertex, the x value of the vertex, is going to be at negative b over 2a. So if you can remember this formula, it's going to save you a lot more time. So my a of this is negative 16, my b is 64, and my c is 0. I'm not going to need to use my c, but that's okay. Negative b, that's going to be negative 64 divided by 2 times a, which is negative 16. So this is going to be negative 64 divided by 2 times negative 16, which is negative 32, and this divides to give you 2. So my vertex is going to be at 2 something. We don't actually need to find out what that height is because all the question is asking is, does the ball reach its maximum height at t equals 2 seconds? Well, the vertex will give you the maximum height, and that is at 2 seconds, so the answer would be yes, it reaches its maximum height at 2 seconds. Question 57. An animal makes a leap into the air. A function for the height, h of t in meters, of the animal above the ground after t seconds is given by h of t equals negative 5t squared plus 12.5t. How long is the animal in the air? Show how you determined your answer. Well, again, we're trying to find out basically when does the animal hit the ground. We need to find the zeros, so we need to find when the height is 0. So 0 equals negative 5t squared plus 12.5t. We could try to factor this, and in order to do that, we'd need to take out a GCF. Negative 5 and 12.5, there's no GCF for that, but we do have a t in each term. So we can pull out a t, and we're left with negative 5t plus 12.5. I know that I also told you to take out the negative, so you could have pulled out a negative 1 as a GCF as well, so negative t, and then had 5t minus 12.5. Either way, you're going to get the same answer in the end. So we're going to set each factor equal to 0, so negative t equals 0, or 5t minus 12.5 equals 0. I'm going to divide negative t by negative 1 to give me t equals 0. And for this one, I'm going to add 12.5 on both sides to get me 5t equals 12.5. And then I'm going to divide by 5, and t is going to equal 2.5. So this is time, so it's seconds. And to find the total time that the animal's in the air, we're going to take away when the animal hit the ground, and by the time that the animal started at. So in this case, the animal is in the air for 2.5 seconds because 2.5 minus 0 equals 2.5. I could have also found out what t was, my zeros, using the quadratic formula, completing the square, graphing, etc. For part B, it says, what is the animal's maximum height? Show how you determined your answer. Well, yet again, we need to find the vertex. We're given the formula h of t equals negative 5t squared plus 12.5t. I can use my graphing calculator and do this pretty quickly, but I'm going to do it the way we did for the last problem. And I'm going to find the x value of my vertex. So it's not actually x, it would be t. T is going to equal negative b over 2a. Well, in this case, a is negative 5, b is 12.5, and c is 0. So that's my standard form of ax squared plus bx plus c. So negative b is going to be negative 12.5 divided by 2 times negative 5. Negative 12.5 divided by negative 10, and that's going to equal 1.25. So my vertex is going to be at 1.25 comma something. In order to find that something, I need to plug in 1.25 for t. So I'm going to find h of 1.25, which means anywhere where I see t, I'm going to be plugging in 1.25. So negative 5 times 1.25 squared plus 12.5 times 1.25. Well, negative 5 times 1.25 squared is 1.5625. And 12.5 times 1.25 is 15.625. Negative 5 times 1.5625 is negative 7.8125. And I'm going to add that to 15.625 to get my answer of 7.8125 meters. So my vertex, I'm going to be adding in this 7.8125. And the question is, what is the animal's maximum height? Well, the animal will reach its maximum height at the vertex, so it will reach its maximum height at 7.8125 meters. Question 58. In your own words, what is the zero product property? Well, the zero product property is if a times b equals 0, then a equals 0, and or b equals 0. So in my own words, I'm going to say if the product of two or more numbers equals 0, then at least one of the numbers must equal 0. For items 59 through 64, solve the equation using any method. So 59, we have x minus 7 squared equals 81. The best method to use is the square root method. So I'm going to square root x minus 7 squared, and I'm going to square root 81. But don't forget, when I square root an equation that's got an unknown, I'm going to have to do plus or minus that square root. Well, the square root of anything squared is going to be that original term. So x minus 7 equals plus or minus the square root of 81, which is 9. I'm going to separate this into two equations. I've got x minus 7 equals negative 9, and x minus 7 equals positive 9. I'm going to add 7 to both sides, and x is going to equal negative 2, or x is going to equal 16. For number 60, I've got x minus 5 times 3x minus 2 equals 0. So this is already factored, meaning I can set each factor equal to 0 and then solve for x. So in this case, I'm going to add 5 and get x equals 5. In this other case, I'm going to add 2 first to get 3x equals 2, and then I will divide by 3 to get x equals 2/3. So my zeros are x equals 2/3 or x equals 5. For 61, I've got 7x squared minus 8x plus 1 equals 0. I can use the quadratic formula for this, or I can try to factor. I don't recommend completing the square though. So I'm going to practice factoring when a is not 1. So the first thing I need to do is a times c, which is 7 times 1, and that equals 7. So factors of 7 include 1 and 7, or negative 1 and negative 7. When I add 1 and 7 together, I get 8, and when I add negative 1 and negative 7 together, I get negative 8. Since b is negative 8, I want this one. Next, I'm going to make my box, and I'm going to put in my first term and my last term because those don't change. So 7x squared and 1. In my other two boxes, I'm going to put the two terms that I found here, the two factors. So negative x and negative 7x. Finally, I'm going to take out the GCF of each column, working from the bottom up, and the row left to right. So first, looking at this column, 7x squared and negative x, my GCF is going to be x. And working negative 7x, 1. Because this first term here is a negative, I'm going to pull out a negative 1, but that's the only GCF I have. Now working with my rows, again, this first term is a negative, so I'm going to pull that out. And for this row, I can pull out not only a 7, but also an x. That means this is going to factor into 7x minus 1 times x minus 1. So once I've factored 7x minus 1 times x minus 1, and I know that's equal to 0, I can use the zero product property to help me. 7x minus 1 equals 0, or x minus 1 equals 0. I'm going to add 1 to both sides and get 7x equals 1, divide by 7, and I'm going to get x equals 1/7. Over here, I'm going to add 1 to both sides, and I'm going to get x equals 1. So my zeros are going to be x equals 1/7 or x equals 1. For number 62, I have x squared minus 10x minus 1 equals 0. And I know that there's nothing that I can multiply to get negative 1, which will add to negative 10. So I'm going to use the quadratic formula. So a is going to equal 1, that's the coefficient of my quadratic term, my x squared. B is going to equal negative 10, and C is going to equal negative 1. My quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this means x is going to equal negative of negative 10 plus or minus the square root of negative 10 squared minus 4 times a, which is 1, times c, which is negative 1, divided by 2 times 1. X is going to equal the negative of negative 10, which is positive 10, plus or minus the square root of negative 10 squared, which is 100, minus 4 times 1 times negative 1, which is going to come out to positive 4. 2 times 1 is 2, so it's going to be divided by 2. And this is going to be 10 plus or minus the square root of 104 divided by 2. So we can leave these as our two answers, or we can find the decimal match for it. So x can equal 10 plus the square root of 104 divided by 2, or x is going to equal 10 minus the square root of 104 divided by 2. These simplify to x will be 10.099, or x is going to be about negative 0.099. Either way you write your final answers will be acceptable. For number 63, I have x squared plus 6x equals negative 8. You do not want to solve any quadratic equations without setting it equal to 0 first, unless you're using the square root method. So the first thing I'm going to do is add 8 on both sides and get x squared plus 6x plus 8 equals 0. I can factor this, so I'm looking for what multiplies to 8 but adds to 6, so 1 and 8, 2 and 4, and I can see 1 plus 8 is 9, 2 plus 4 is 6, so these are going to be my factors. X plus 2 times x plus 4, and that's going to equal 0. So using the zero product property, x plus 2 equals 0, or x plus 4 equals 0, and I'm going to solve for x. So I'm going to subtract 2 and get x equals negative 2, or I'm going to subtract 4 and get x equals negative 4, and those are my two zeros. Finally, we have x squared minus 7 equals 9. Well, I want to combine like terms first, so I'm going to add 7 to both sides. And that's going to get me x squared equals 16. I could bring the 16 over to the other side and try to factor, but what's nice about this is I can actually use the square root method. So I'm going to square root x squared, and I'm going to square root 16. But don't forget, when you square root a variable, you've got to add in that plus or minus on the other side. So x is going to equal plus or minus the square root of 16, which is 4. Therefore, my zeros are x equals -4 or x equals +4. Question 65. A farmer plants apple trees. The total number of apples can be represented by the function a of t equals 300t minus 5t squared, where t is the number of trees that he plants. Sketch the graph of a of t equals 300t minus 5t squared on the coordinate plane below. Show the points where t equals 0, 10, 20, 30, 40, 50, and 60. So I'm going to make a table of values where I have a of t equals 300t minus 5t squared. So I've got t and I've got a of t. And we're going to be looking at t when it's 0, 10, 20, 30, 40, 50, and 60. So all I need to do is plug in those numbers. So 300 times 0 minus 5 times 0 squared, and that's going to equal 0. When I have 10, it's going to be 300 times 10 minus 5 times 10 squared. And I'm just using my calculator, and that's going to be 2,500. 300 times 20 minus 5 times 20 squared, and that's going to be 4,000. Then I've got 300 times 30 minus 5 times 30 squared, and that's going to equal 4,500. 300 times 40 minus 5 times 40 squared, and that's going to equal 4,000. 300 times 50 minus 5 times 50 squared, and that's going to equal 2,500. And finally, 300 times 60 minus 5 times 60 squared, and that's going to equal 0. So we need to sketch the graph of these points. So we've got 0, 0. We've got 10, 2,500. We've got 20, 4,000. 30, 4,500. 40, 4,000. 50, 2,500. And 60 is 0. So our graph is going to look like this. And that's the sketch of a of t equals 300t minus 5t squared. Next, the farmer wants to be able to harvest at least 4,000 apples, at least. So use your graph above to solve the inequality 300t minus 5t squared is greater than or equal to 4,000. Well, we know that this is a of t, and we want to know when is a of t greater than or equal to 4,000. Basically, when are the y values on my graph greater than or equal to 4,000? Well, if we look at our graph, this is 4,000 right here. So this is when a of t equals 4,000. We want all values of t that give us a y value greater than or equal to 4,000. So basically what I have is this graph, and this line is 4,000, here at 20, and here at 40, and anywhere in between, so basically all of this, are values of t that will give me an a of t that is greater than or equal to 4,000. So my solution is going to be 20 is less than or equal to t, which is less than or equal to 40. Or I can write it in this notation, 20 to 40, inclusive on both sides. Finally, we're asked, what is the meaning of your solution in the context of this situation? Well, we know that the farmer wants to harvest at least 4,000 apples. T is the number of apple trees, so we need between 20 and 40 apple trees inclusive so that the farmer can harvest at least 4,000 apples. So in writing, if the farmer plants between 20 and 40 apple trees, inclusive, so that means including both 20 and 40, then he should be able to harvest at least 4,000 apples. Question 66 says the equations y equals x squared minus 4x minus 5 and y equals 7 are graphed on the coordinate plane below. So this is our graph of y equals x squared minus 4x minus 5, and this is our graph of y equals 7. What are the solutions to the equation x squared minus 4x minus 5 equals 7? So the question is, when does this graph have y values equal to 7? That is basically the intersections of our graph at x equals -2 and x equals 6. So those are our solutions. Now, we could sit here and solve, x squared minus 4x minus 5 equals 7, take away 7, x squared minus 4x minus 12 equals 0. We can see that that will factor into x minus 6 times x plus 2, and we'll get the same solutions. But why go through all of that work when you can look at the graph? Next, part B says, what are the solutions to the inequality x squared minus 4x minus 5 is less than or equal to 7? So we had this graph. Here was when y equaled 7, and we know that at x equals -2 and x equals 6, the graph equaled 7. We want to know is, when is this graph less than? When does it give us a y value that's less than or equal to 7? So basically that's going to be all of these y values, which is all of the x values in between -2 and 6. So our answer is going to be -2 is less than or equal to x, which is less than or equal to 6. Or we can write it in the notation with -2 comma 6 and brackets to show that it includes those two numbers. For items 67 and 68, determine the side of the right triangle marked x. Well, since we know that these are both right triangles, we can use Pythagorean's theorem to help us determine the missing side. Pythagorean's theorem says a squared plus b squared equals c squared, where a and b are our legs and c is our hypotenuse. Our hypotenuse is always the side opposite the right angle. So if this is our right angle, this is always the hypotenuse. So it doesn't matter which one's A and which one's B. We'll say 5 is A, 12 is B. We're going to have 5 squared plus 12 squared is going to equal x squared. 5 squared is 25, 12 squared is 144, equals x squared. So 25 plus 144 is 169. That equals x squared. So I'm going to square root both sides, and I'm going to get x equals 13. It's a side length, so I know that it's not going to be negative. So x equals 13. Same thing for 68. We're going to use a squared plus b squared equals c squared. But this time, one of our legs is a, x is b, and our hypotenuse is c, and we know our hypotenuse. So we're going to have 7 squared plus x squared equals 10 squared. Well, 7 squared is 49, plus x squared equals 10 squared, which is 100. I'm going to subtract 49 on both sides because I want to get x squared by itself, and that's going to give me 51. So when I square root both sides, I'm going to get x equals the square root of 51. So that leg is going to be equal to the square root of 51, or I can round it and say x is about 7.141. On the coordinate plane shown below, 3 line segments are shown with their coordinates. For items 69 and 70, find the distance between each pair of points. So for 69, we're going to find the distance between 7, -2 and -6, 3. You can use your graph and do Pythagorean's theorem and find the lengths, or you can use the distance formula. The distance formula is Pythagorean's theorem, but in a simplified way, and it's given to you, so I'm just going to use that. The distance is going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. This is going to be the square root of -6 minus 7 squared plus 3 minus -2 squared. -6 minus 7 is -13 squared, and 3 minus -2 is 5 squared. So square root of -13 squared is 169 plus 5 squared, which is 25, and that equals the square root of 194, and you can leave your answer like that or round it to about 13.928. Number 70, we're looking for the distance between -6,3 and 2,9. So distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared, which is going to equal the square root of 2 minus -6 squared plus 9 minus 3 squared. This is going to be the square root of 2 minus -6 is 8 squared, plus 9 minus 3 is 6 squared. 8 squared is 64, 6 squared is 36. So the square root of 64 plus 36 is the square root of 100, which equals 10. And that concludes the Algebra exam review for Unit 4, Topic 3.